This lesson is going to be about electric forces. So if we place a charge on a conductor, what it's going to do is very quickly distribute itself over the conductor's surface. So if I had negative charges on a piece of metal, they're not going to stay together because like charges repel. So very quickly you're going to see those charges spread out evenly over the surface. This is extremely fast. And once they're at this point where they're all spread out, this is called electrostatic equilibrium. It's equilibrium because there's no acceleration or no changes, and it's electrostatic, static meaning no movement at all. So as a review, let's remember that charged objects that have like charges repel each other, and charged objects that have opposite charges attract each other. What we're going to talk about today is what is this force that acts in between these charges? How do we figure out the amount of the force, the magnitude of the force between two different charges? So we're going to use what's called Coulomb's law. Coulomb's law will tell us the force between two charges, or between 2 point particles. And you'll notice that it has magnitude in it because we're looking at the amount of the force, not the direction. The direction of the force you can tell by whether it's a positive and a negative charge, or a negative and a negative, or a negative and a positive. That'll tell you the direction. But this just tells us the magnitude of the force. So on your equation sheet, you'll see that the force subscript E, that's the electric force, is equal to K, which is a constant, and I'll talk about that in a second, times the magnitude of charge 1, Q1, times charge 2, Q2, divided by r squared. So F is the force between particles. Just like any other force, we measure it in newtons. Q1 is the magnitude that has no sign of the charge on particle 1. And the charge is measured in a unit called coulombs, which is what we use to measure charge. Q2 is the magnitude with no sign, so it's not positive or negative. We just put the amount of charge on particle 2 in coulombs, and r is the distance between the center of these two particles. So from charge 1 to charge 2, the distance is measured in r. K is the Coulomb's law constant. This is on your AP Physics 1 equation sheet. It's 9 times 10 to the 9th newtons times meters squared divided by coulombs squared. So according to Newton's third law, all of our forces are going to come in pairs. So every force has an equal and opposite force that goes back. If you push on the wall pushes back on you with the same force. This is also true for electric forces. So the force that this positive charge exerts on this positive charge equals the force that this positive charge exerts on this positive charge. So the magnitude of these forces are the same. They're equal in magnitude, but they're opposite in direction. You can see one goes to the right and one goes to the left. This is true for two positive charges. It's also true for a negative and a positive. In this case, this one goes to the left and this one goes to the right, but the amount of the force is equal. And that makes sense from the equation, because in the equation you can see that it doesn't matter which charge we're looking at. The effect, if I put Q1 times Q2 or Q2 times Q1, you'll get the same force from it. So you might notice that this equation looks similar to our force of gravity equation. When we talked about the force of gravity on an object, we had G as a gravitational constant times a mass times another mass divided by the radius between them squared. That was the gravitational force between two objects. These equations look pretty similar. These are electrostatic or electric force and gravitational force are in the same category of forces. They are called long-range forces. So the force between two charged objects is a long-range force like gravity. Long-range means that long-range means that it acts over a longer distance, and as the distance increases, the force decreases by a factor of r squared. So very quickly that force will get less and less. So let's do an example. We're going to use Coulomb's law, and we're going to have a small positive charge called Q dot placed at the point where there's this black dot. So there's a charge here, Q dot. We want to look at 4 different situations and figure out where is the force on this dot the largest, and where is the force on this dot the smallest. So is it here, here? We've got 4 different cases to consider. So we'll start with A. Where is the force on the black dot the largest? So the things that are different in these situations are the charge that is applying the force. So in this case, we're applying a charge of just Q nearby. In this case, we have 2Q. This case has 2Q nearby, and this case has Q. The other thing that's different is the radiuses. So we're going to look at this equation and figure out where the force will be the greatest. So first, for part A, the force on the dot, we have 2 charges, Q dot and Q. So those go into our equation, and we're going to take the magnitude of those and divide it by the radius, which is given to us, radius squared. So this is going to be our force at point A. So now we're going to use that and compare it to the other places. So at point B, we now have 2Q times Q dot. So 2Q times Q dot on the top. And on the bottom, we have 2R, and that's squared. Make sure you square the 2. So it's going to become 4R squared. So this is our force on the dot in the second place. We're going to simplify this because we have 2 over 4. That's going to become 1/2 times Q dot over R squared. In the third case, we have 2Q as our first charge and Q dot as our second charge. So our force will be K times 2Q times Q dot, and the radius is R, so it's over R squared. So we can pull out this 2 because we want to make comparisons. So we'll pull out the 2, and we get Q dot over R squared. In our last case, our force is equal to, we have just Q and Q dot as our charges, and our distance is 2R. So we're going to make it 4R squared on the bottom because you have to square the 2 and the R. And then we can pull out this 4 so we can compare to the others, and it becomes 1/4 Q dot over R squared. So now we have 4 different forces, and we can see which is the largest. Well, the largest is going to be the one that has the 2 on front of it. So C has the largest force. It has the largest charge, smallest distance, so it has the largest force. The force is the smallest on D. D has just a charge of Q on both, and it has the largest distance. And mathematically, you can see that it has the smallest force. So D will be the second answer.